space. Yeah, group 1, ammonium, calcium, strontium, barium. So magnesium is not one of the exceptions, so it's going to precipitate. The mass of carbon-13 is exactly 13U. False. 13, an element has two isotopes, 6U, which is 10%, and 7U, which is 90%. The atomic mass is, this one doesn't even require calculation. You should be able to do this in your head. Which one should it be? B. B, correct. 6.9.
Can we go over that?
Oh, okay, we can go over that. If it were 100% 6, what would the mass be, the average mass be? So if it's 100% 6, lithium 6, is that lithium? No, element 6. If it's 100% element 6, it's 6. That would be 0%. If it's 0% element 6, then it's going to be the other one, which is 7. And so this is the range here. Well, what do we have? We have, it's 10% element 6. So it's 10% element 6 brings it here. Or, in other words, we could do it based on, if it's 100% element 6, it's got to be 0% element 7. And so this is the case. 100% element 6, 0% element 7, the average is going to be 6. If we're at 0% element 6, 100% element 7, then the average has got to be 7. And so what we have here is we have 90% element 7, 10% element 6, which brings us here. And so we're 90% of the way to 7, which means we're going to be 6 point. Let's say we're halfway. If it's 50-50, if it's a 50-50 mix, what is halfway? 6.5. So if it's a 50-50 mix of 6 and 7, the average is going to be 6.5. That's 50% of the way across. If we're 60% of the way, what do you think it's going to be? 6.6. So that would be 60% 7, 40% 6. We're at 6.6. 6.7 would be 70% of the way, 6.8 would be 80% of the way, 6.9 would be 90% of the way, and if we get 100% of the way, we're going to be at 7.0. That's how I would do it mentally in my head, or just plug it into the equation. We could plug it into the equation, you know, the equation for the isotopes. Do you have the equation for the isotopes memorized? That the average atomic mass is equal to the percent abundance of isotope 1 divided by 100 times the mass of isotope 1 plus, that was the sum of the terms. So we did a couple of examples of that. We did a couple of examples of this, estimating it too. You can look it up. It's in the book also, the equation. You can just plug it into the equation. Just plugging it into the equation just takes a little bit more time. Are we okay with 13 then? Let's go to 14. No object exists that weighs exactly 1 U. It's true. Mass number is not mass. That's true. What is the mass number defined as? Number of protons plus the number of neutrons. The mass number is not a mass, it's a number. It's the number of protons plus the number of neutrons. But it's close to the mass because the protons and the neutrons weigh about 1, and they make up almost the entire mass of the atom. So it's close to the mass, but not mass. U-238 contains how many neutrons? We have to figure out how many protons U-238 contains. You know how many protons uranium? You'll have the periodic table, so you can look it up on the periodic table. Uranium contains 92 protons. 92 protons. So 92 plus the number of neutrons equals 238. So it's got to be 146. No answer that's even close. How many water drop molecules? How many water molecules are in one drop of 0.05 milliliters of water? No, not A. Avogadro's number is a mole of water. Do you know how much a mole of water weighs? 18 point something grams, 18.02 grams. 18.02 grams is how many milliliters of water? 18.02 grams of water is how many milliliters of water? 18 milliliters of water. We know that because of the density of water. What is the density of water? Everybody should have it memorized by now. What is the density of water? Is that as precise as you can get? 1 gram? Yeah, 1.0 or maybe 1.00 grams per milliliter. So, did anybody get a different answer than Avogadro's? So if we have 0.05 milliliters of water, how many grams is that? 0.05 milliliters is how many grams? Do you know the density of water?
0.05 grams.
It would be 0.05 grams. So if we have 0.05 grams of water, how many moles of water is that? Is that 1 mole of water? No, it's a lot less than 1 mole because 18 grams is a mole of water. And so since it's only a fraction of a mole, then we'll only have a fraction of Avogadro's number. So this is dimensional analysis. Can you just do the calculation and see? If we have 0.05 grams, what do? You go grams to moles, moles to molecules. This is standard. This is all of chapter 7. Pretty much a gram to mole conversion and a mole to number conversion. How do we do a gram to mole conversion? What do we need? We need the molar mass. Molar mass, you don't even have to look at the periodic table. You should know. What is the molar mass of oxygen? 16.00. What's the molar mass of hydrogen? 1.01. So this is going to be 2.02. So this is 18.02 grams per mole. So I do. This is a very simple, or quick, not simple, but very quick calculation. Very quick calculation because 0.05 milliliters of H2O. And then I know the density. Everybody should have the density memorized. 1.0 or 1.00. We'll go with 1.00 the grams per 1.00 grams per milliliter. That's the density of water. The 2 or 3 sig figs, we should know it. To 4 sig figs, we got to look it up in the table. And so this gives me grams of water. Milliliters of water cancel. Make sure your units cancel. This is how you can tell. One of the biggest errors that the student makes is they don't write the units. Let me tell you, you can only make it so far without writing units. Eventually, you're going to have to start writing units. Otherwise you have to pick a different profession because you aren't going to get to the higher level classes. You aren't going to make it. Everybody, once you get to a certain level, everybody writes the units, pretty much. And those who don't are they decide to pursue something else. And so it's called they call that the weeding out process. But anyway, we'll get grams of water, and then from grams of water we could go to moles of water, because we know that there are 18.02 grams of water for every mole of water. And so I have the moles, but moles is like a dozen, it's a counting unit. And so if I have 13 dozen, how many individual units do I have? I'd have 13 times 12. Well, if I have this many moles of water, how many units do I have? Well, it's Avogadro's number. Do you have Avogadro's number memorized in 4 sig figs?
6.022.
Yeah, good. 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd H2O molecules per mole of H2O molecules. You gotta bring a pen. Pen's are drying up. And so the units cancel, that leaves us with H2O molecules, which gives me what? So let's take a look. I don't know what the answer is, so I'm gonna just calculate. 0.05 divided by 1802 times 6.022 times 10 to the 23rd. 1.67 times 10 to the 21st. .67 times 10 to the 23rd molecule. We're only allowed 1 sig fig, so this is going to round to 2 times 10 to the 21st molecule, which overestimates it by quite a lot. That's a pretty big round-off error right there. It's a huge number of molecules. But we see 18. The cathode ray tube was used to discover the electron. True. 19. Water contains 1/3 oxygen by mole. 33.3% oxygen by mole. False? Anybody think otherwise? Okay, for water, I have 2 hydrogens for every oxygen. So if I look at by atom, 1/3 of the atoms in water are oxygen. If I look at by dozen, I could have 2 dozen hydrogen, 1 dozen oxygen. And so it'd still be 1/3 oxygen by the dozen. If I look at it by moles, I'll have 2 moles of hydrogen for every 1 mole of oxygen atom, which is 1/3 oxygen by mole. And so it's by atom, by mole, by dozen. The mole is a counting unit, so this is true. Water contains 1/3 oxygen by mole, but not by mass. By mass, it's like 89% oxygen by mass. The oxygen weighs a lot more. But by atom, by dozens of atoms, or by moles of atoms, it's going to be 1/3. 20. CO2 can be combusted further to form CO3. It's false. It's false. Why is that false? Didn't we see CO3 before? You've seen CO3 before, but it doesn't look like that. CO3 that we know exists is CO3, which is called what? Well, it has a 2 minus charge. We see CO3 with a 2 minus charge. That exists. That would be called carbonate. This has no charge, so we would call this carbon trioxide. So we'd be going from carbon dioxide to carbon trioxide. Why can't carbon trioxide exist? Or why can't we just burn the carbon dioxide more? Did you know you can burn carbon monoxide? Carbon monoxide can be burned to form carbon dioxide. How about carbon dioxide? Can we burn carbon dioxide to form carbon trioxide? No, but why not? Hey, does perchlorate exist? I know perchlorate because we just saw that huge explosion with perchlorate, ClO4 minus. Does perchlorate exist? Why not? Because perchlorate would result in a more massive explosion than we just saw if we had perchlorate. Perchlorate would just be one more oxygen than perchlorate, which would be ClO5 minus. Why not? See, this is the reason why you'll have a huge advantage if you're one of those people who review things every day. If you're one of those people who review things every day, then you can start making connections with other things. Like, for example, perchlorate, we know it stops there because chlorine is in the +7, which is at its max. The max positive charge on chlorine is +7. What is the max positive charge on carbon? +4. See, the thing is, you can't make these connections unless you've seen this stuff and you see it repeatedly, and then it's easy to make these connections. It's very easy to make these connections if you've seen it so many times. You know, it gets boring. Then you start looking for connections because you're bored. You already have it memorized. And so you're going to have a huge advantage, but the problem is lots of other people do this, like at UCLA, because they want to get to medical school. And so it's very hyper competitive. And so pretty soon you have to do it just to keep up. You know, not to raise the bar, but just to keep up. And so in this case here, what is the charge on carbon in CO2? +4. What is the charge on carbon in CO3? You know what? If you go back in your notes, I already talked about this. So this is why I asked it on the test. I talk about this every year. But the charge on carbon is plus, no, it's +6. +6. +6 is not, it exceeds the maximum charge here, which would be a +4. We aren't going to go to +6. That's the reason why. Most of the eights are maxed out. That's the maximum number of oxygens you can put on there. They just screwed up with chlorate and perchlorate. Because perchlorate's just so unstable. They thought it maxed out at 3 oxygens, ClO3 minus. It didn't. It maxed out at 4. But they had already named it chlorate. And so it can't reverse that. And so they had to come up with a new one for the 4 oxygen, which was perchlorate. Well, anyway, so the answer is no, because it would make carbon +6 and outside its range of normal charge. Sometimes you can get something outside the range of its normal charge. Do you remember seeing an example of something outside its range of normal charge? Yesterday. It's kind of exotic species. Well, now it's getting more difficult, but to make these connections because you don't have enough time. The other thing you need to, because it's all new stuff. You need your brain to make all the neural connections between all this stuff. That takes time, but if you're already mentally prepared, then the connections can be already made. They're saying that in the discovery of penicillin, you know, it was a by chance discovery, but that by chance discovery of penicillin could have easily have been missed if Pasteur, is it Pasteur who discovered penicillin? If Pasteur didn't already have all these connections made up in his mind, he wouldn't have never connected it. You know, for example, when he came back, do you know about the discovery of penicillin? Basically, he had some bacteria cultures, and the story goes like this, and I'm not sure how accurate it is, but he decided not to wash the petri dishes, just leave them sitting on the shelf. And they come back and to wash them and notice that the bacteria were dead. And so something got in there and killed them all. And that's how they discovered penicillin spores. That's what got into that, but could have just as easily just washed those, you know. So if it was just a dishwasher, a lab tech dishwasher, they probably would have went in and washed it and hadn't noticed anything, you know, unusual or anything different. And the only reason he knew it was unusual is because they say his mind was prepared. Chance, there's a quote, chance favors the prepared mind. You know, you can take it. And so, did you see an unusual charge before? I don't know if you remember this one, but there was an unusual charge. Does anybody remember the unusual charge? It was sulfur. This is very unusual. Sulfur is normally maxed out, like in sulfate, it's maxed out at plus. What's the maximum positive charge in sulfur? 6. This is plus 6 here. But when we calculate the charge here, it's plus 7. So this is a very unusual species. But there's more to it structurally. I mean, it's not totally plus 7, but we'll look at that later. That was very unusual because that one outside the range. Normally we don't see that. We don't see that. And so carbon trioxide, we wouldn't expect to see that because, you know, this means that carbon is element number 6. And element number 6 has 6 protons and how many electrons? Element number 6 has 6 protons and 6 electrons. If this were plus 6, it's lost every single one of its electrons. Very unusual. Well, let's move on. 21, the oxidation state of chlorine varies from -1 to +5. It's false. What does it vary from?
-1 to 7.
Yeah, -1 to +7. That's correct. -1 to +7. We had just talked about that one, right, with the perchlorate. When aluminum is oxidized, AlO2 is a potential product. If we oxidize aluminum, we're going to form oxides of aluminum. Is AlO2 a potential product? No. AlO2 is not a potential product. Why? The charge, what's the charge on aluminum? It's +4. Is +4 an okay charge for aluminum? No, it's not an okay charge for aluminum. What should the charge be? +1, +2? It should be +3. +3 is going to be the max positive charge on aluminum. false. 23, a carbon-12 atom in methane weighs exactly 12 U. That's true. 24, the reaction of fluorine plus sodium iodide fits a single replacement pattern. Skip that one, because we aren't doing single replacement here. 25, gas formation is a driving force for redox. That's false. That's false, but gas formation is a driving force for what type of reaction? Metathesis. So even though this is for redox, gas formation is a driving force for metathesis. That's true. 26 is this compound, contains carbon and hydrogen and has a mass of 58 U. What is its molecular formula? So this is just determining first the empirical formula and then determining the molecular formula. So what are the steps involved in this? Well, what is a formula? Is a formula a mass ratio or a mole atom ratio? Oh, actually, we're past time. Sorry. Let me pause here. Stop.